Good morning. Session 10 on chapter triangles. So this is the last session of this chapter. We will start again with an optional exercise. In yesterday's session, we started optional exercise and all the simple sums we had solved. We are left with few remaining sums. So out of 10 sums, in yesterday's session, we have done first one, third one, fourth, fifth, seventh and eighth. So in today's session, we will complete second, sixth, ninth and 10th. We'll start with the second question. I will number it properly, even you all number the questions correctly. So, second one, the figure given is, it is a triangle but not a right angle triangle. ABC is a triangle, but in that DM is perpendicular to BC and DN is perpendicular to AB. Join DN is given. So this is perpendicular. This is perpendicular. That means if I actually go to C, here this is also perpendicular. Okay. Let's write down. Given in triangle ABC, BD is perpendicular to AC. So this BD is perpendicular to AC, that is what we have marked. Then we have DM perpendicular to BC, DM perpendicular to BC and we have DN perpendicular to A. To prove, first part what we have to prove, DN square is equal to DN into MC, and second one we have to prove DN square is equal to DM into AN. DM square and DN square, that means we are looking for those triangles. Okay, proof part. Whatever we use the technique to solve this, the same technique is used to solve second half also. So let's consider in whole triangle first. In triangle ABC, we know that BD is perpendicular to AC, right? So if BD is perpendicular to AC, I can tell that angle BDC is equal to 90 degree. BDC is equal to 90 degree. How can we split BDC? We can split BDC as this. BDC can be split as BDM plus angle MDC is equal to 90 degree. It is nothing, we have just split this BDC. This plus this is equal to 90. Right? I will write this as equation 1. Keep this as it is. Now choose this triangle here. In triangle DMC, so DMC, we will write angle sum property, children, here. So how do you write? Angle DMC plus angle MDC plus angle NCD is equal to 180. This triangle we have chosen angle sum property. So which angle is 90 degree? Angle DMC. Where is it? Angle DMC is 90 degree here. This angle is 90 degree. So this is 90. Angle MDC as it is plus angle MDC plus angle MCD is equal to 180. If I shift this 90 this side, I will get angle MDC plus angle MCD is equal to 90. Okay. So we already have this here. Angle MDC. Angle MDC is here. Angle MCD is not known. Do we know what is the measure of MDC? Yes. Now what I will do, children, here, this can also be written as angle MDC is equal to 90 minus angle BDM. Can I say that? And can I substitute the value of MDC here? I will do it. Instead of MDC, I will write 90 minus angle BDM plus angle MCD is equal to 90. 90 and 90 I can cancel. Minus BDM, if I shift that side, what do I get? I get MCD is equal to BDM. MCD, this angle is equal to BDM. That is what we proved here. Is this very clear? Keep this as it is. The second half I will do. Now choose these two triangles and prove that those two triangles are similar. In triangle DMC and triangle DMB. Right? First of all, 90 degree we will write. Angle DMC is equal to angle DMB is equal to 90. Reason, DM perpendicular to BC. Second angle already proved here. Can I use that? I will write angle NCD is equal to angle BDM. Proved above. Are these two triangles similar? Triangle DMC is similar to triangle DMB by double A criteria. Write the proportionality side with this respect. So what we will do, children, first we will write whatever we want. Then we will see exactly what sides we want, how we want to write here. According to this, it is DC upon DB is equal to MD upon BM. Right? So actually if you want to write, it is whatever, however it is given here. But with these we will not get here. That means I want third side also. Now third side, if I want, it is CM or M. This is the third side, CM, and this will be the third side. So this is MD. MD into MD, we will choose this. It is MD square is equal to BM into CM. Check here, it is BM square. We'll make this as now BM square is equal to, BM is anyways not there, keep BM as it is. Is CM there? Instead of CM we have MC. Very easy. Let us write it off. Then we will think how they have used it. Either to read from here or read from here. That will be a confusion always. Okay, we got it. But we want BM square is equal to DM into MC. I have something on BM here. How to make it MC? Look at here. BM is what? This. Now this is 90 degree. This is 90 degree. That means is that a rectangle? DMBN is a rectangle. Directly. No proof. How we got it? Not required. DMBN is a rectangle. In rectangle, opposite sides are equal. Therefore, BM is equal to DN and MD or DM is equal to BN. Keep this as it is. This implies DM square is equal to, instead of BM, I will use DN. DN into MC. Right, children? Very clear? We arrived at the first one. Now, similarly, we have to choose the other two sides of a triangle and do it similarly like that only. So there again what we will tell? We will tell DM is perpendicular. It is 90 degree. This angle can be split as this plus this. Again, the same thing how we had written, we have to prove it. Let us do that. Shall I erase this part so that it will be easy for me to do the next part there. Similarly, we'll be doing it. Or would you like to take that as a homework, the second part of it? Same thing. Now what you will do in the second part? In second part you will tell that here, you will choose this triangle. You will just say that this angle plus this angle is equal to, this angle is 90 degree or this angle is 90 degree, right? Take the whole part of a triangle. Or you want me to do it? I will also do it because it should not lead to confusion, because there are so many triangles in them, which to take, which to choose, you will not understand. I will do that. No homework will be given in that. So let me rub this part and immediately start with the second one. Again we will start with the same thing. So I will again tell that here, same starting how we started, in triangle ABC, BD perpendicular to AC. Now again this BD was perpendicular to AC given, right? With that respect, this was 90 as well as this is 90. See children, this is the triangle given. Now this is BD. Forget about the other parts. This is 90 and this is 90. Now here you have all these parts. So that part is also 90. This part is also 90. So if that is 90, how do you write again? Angle BDA we will consider. BDA is equal to 90 degree. But how do we write BDA? We write BDA as BDN, angle BDN plus angle NDA is equal to 90, right? So we will consider this as equation 2. The equation 1 we had taken. We will rewrite this later, like that how we had written. Choose this triangle now. Same like here how you had chosen, choose that triangle. I will write now in triangle AND. Okay, angle some property we will write. So angle NDA plus angle DNA plus angle NAD is equal to 180. Angle sum property. Okay, so NDA plus this, all the three angles. Now which angle is 90 degree here? DNA is 90 degree. So angle NDA plus 90 plus NAD is equal to 180. 90 if I shift that side, angle NDA plus angle NAD is equal to 90 we got. Okay, NDA here we have it here. So angle NDA can also be written as 90 minus angle BDN. Let me substitute the value here. 90 minus angle BDN plus angle NAD is equal to 90. 90 and 90 cancel. Minus will go that side. So NAD is equal to angle BDN. Keep this as it is. NAD is equal to BDN. Okay, these two are equal. Easy for identification. Double A criteria we can apply. So let me rub this part. Further, we know how to solve it now. Choose the triangles for similarity. In triangle AND and triangle BND. So first of all, angle AND is equal to angle BND is equal to 90. Present DN perpendicular to AB. Then angle NAD, that is what we have written now. Yes, NAD is equal to angle BDN. proved above. Therefore, triangle AND is similar to triangle BND by double A criteria. From double A criteria, we will just write, children, first the sides. Then we will see how to change it. AD upon BD is equal to ND upon BN. I am just writing however it is given here. I can't do anything, no common sides or something we have. That means I have to go for a third angle. So this is third angle, means AN I will get here now. Divided by, for this AN is the angle, for this BN is the angle or ND. Choose these two. ND into ND, ND square is equal to AN into BN. It is ND square, DN square. We'll write this as DN square is equal to AN as it is. Yes, AN as it is. We have BN here and we have DN here. Look at the previous part, it was a rectangle. So since it is a rectangle, what is BN is equal to? Is BN is equal to DM? Directly I will write here as BM. DM. Reason, I will write here DM is equal to BN. Proved above. Right? Previous part we have already written it is a rectangle. Hence proved. So simple one, but we need to identify what triangles we have to use and do it. This is how we complete it. We'll start with the next one, that is sixth sum. Prove that the sum of the squares of the diagonal of a parallelogram is equal to the sum of the squares of its sides. It is somewhat similar to like square of the sum of the square of the sides of a rhombus is equal to the square of the diagonals. But there, rhombus all the four sides were equal. So let us assume that it is a parallelogram. A, B, C, D is a parallelogram given. ABCD is a parallelogram, then AC and BD are the diagonals. So AC and BD are the diagonals. So here now when we see, I just draw it, it is not exactly looking because some for construction are required to draw some height to that. So let me consider this to be a parallelogram. Okay. Okay, to prove AC square plus BD square, sum of the squares of the diagonals of a parallelogram is equal to the sum of the square sides of the square of the parallelogram. CD square plus AD square. That is what you have to prove here. Construction. Draw CM perpendicular to AB and DN perpendicular to AB. So it's a height. What we have drawing here perpendicular is nothing but height. CM perpendicular to AB and DM, it is nothing but the height of the parallelogram. Okay. Now what we will do first of all here, we will choose these two triangles and prove that these two triangles are congruent, not similar, congruent. Prove in triangle AND and triangle CMD. First of all, I will write angle AN. So once again, we will read the triangle properly from each vertices wise. So this I have taken C and D, so it is D N A. Always read it from the same vertices as you read from the other side of the triangle also. Angle D N A is equal to angle CMB is equal to 90 by construction. Okay, next part. Can I tell AD is equal to BC? Opposite sides of parallelogram. Next one. I am done with one angle. I am done with one side. Now here it is some other side and some other angle. But it is a 90 degree and a hypotenuse. That means I can do this by RHS. But what is another side? Can I tell DN is equal to CM? Altitudes are equal. Why? Because in the parallelogram, if you draw the height, they have to be equal. Altitudes are equal. Therefore, triangle DNA is equal and congruent to triangle CMB by RHS congruence rule. Okay, from this I can tell that AN is equal to BM, CPCT. So this part is equal to this part, CPCT part. Very clear? Okay, now what I will do is I will drop the whole thing because I have to prove the actual thing what we have got, that is this part we want. We only proved congruency because I had to prove that these two sides are equal. Very clear, children? I am going to drop this from the beginning now and solve the further proof. So you all can copy down this till here. So from congruency we prove that those two sides are equal. Now choose triangle and start applying Pythagoras theorem wherever we have 90 degree part here. Now suppose here if I have to see and this part if I have to see with respect to diagonal. Choose with respect to diagonal, children. For example, now if I want AC as a diagonal, AC square I have to get as a hypotenuse, which triangle should I choose? I have to choose in triangle AMC, angle M is equal to 90 degree. So can I tell AC square is equal to AM square plus CM square? Can I tell this? Right? Because I wanted hypotenuse as this, that we have to prove it there. Reason, Pythagoras theorem. AC square as it is, AM square can be written as AB. See, AB is again one side. I can also write this plus this, but it is of no use. AB plus BM. AM can be written as AB plus BM whole square plus CM square. AB square plus BM square plus 2 times of AB into BM plus CM square. AB square we want in the question, in the solution. So don't do anything to this. Now look at BM square and CM square. See what you can do. AB square I'll write as it is. Where is BM square? Is here. Where is CM square? Is here. BM square plus CM square is nothing but BC square. Plus, keep this as it is. 2AB into BM. Right? Don't do any changes here. Keep it as it is. Reason I will write here. In triangle CMB, so it is BC square is equal to BM square plus CM square. Equation 1. AC square. Okay, children. Similarly, another part of triangle where we have a diagonal BD. So what triangle I have to choose with respect to 90 degree angle? 90 degree will come here. I want BD square triangle. So BD square if you want, where is 90 degree? This is the part. So in triangle, I can say here as BDE ND. This triangle I am choosing in a parallelogram here because I want in terms of BD square. Angle N is equal to 90 degree. So it is BD square is equal to DN square plus BN square. Pythagoras theorem. BD square as it is, DN square also as it is, plus BN can be written as, see here, this is BN here, I can write this as whole AB minus AN, okay, whole square. DN square plus AB square plus AN square minus 2AB AN. Okay, keep this as it is. Later, keeping this AB square as it is, DN square and AN square, where it comes DN square and AN square is nothing but AD square. AB square plus AD square minus 2AB and AN. Now here I have AN, I have here BM. Is AN equal to BM? Can I write it here? So instead of this, I will write this as BM. Okay? And see, wherever I am underlining this, do the same thing. Now in reason, first of all, I will write in triangle AND. So AD square is equal to AN square plus DN square, and AN is equal to BM. This much I have used here. Equation 2. This is BD square. Add equation 1 and 2. So when I add equation 1 and 2, AC square plus BD square is equal to AB square plus BC square, AB square plus BC square plus 2AB dot into BM plus AB square plus AD square minus 2AB into BM. Minus 2ABBM plus 2ABBM will get cancelled. AB square, BC square, AD square, all the sides are there. But I have 2 times of AB square which I actually don't want. Instead of that, I wanted here CD square. Is AB is equal to CD? Opposite sides of parallelogram are equal. 1 AB, no, I will write it as CD. So AC square plus BD square is equal to AB square plus BC square. Instead of AB, I will use that as CD square plus AD square. Reason, AB is equal to CD. Hence proved. That is what we wanted to prove. In a parallelogram, square of the diagonals is equal to sum of the squares of all the sides of a parallelogram, right? So next one, ninth one. Ninth sum is almost similar to the first one, that is in session 1 yesterday, not session 1, sorry, session 9. Yesterday first sum what we had done, it is similar to that. Let us quickly finish that. In figure, D is a point on side BC of a triangle. So this is the triangle given. So this is B, this is P, and this is C, this is A. This is A. Such that given In triangle ABC, it is given such that BD upon CD is equal to AD upon AC. Okay, this much is given. Prove that. To prove AD is the bisector of angle A, of angle BAC, what they have asked. BAC is nothing but angle A. Construction. So what we will do in construction here is produce BA to D is already over, to E, and join EC such that AE is equal to AC. So this one we are joining here. This is point E. So this point, this line and this angles are equal. That much is given. No parallel here. Other way, and the previous somehow it was that AD was parallel to this part, right? Here nothing is parallel, but it is equal. Produce BA to E and join EC such that AE is equal to AC. Okay, keep this much only here. Proof. Let us use as again angle 1 and 2 only and do it. So AE is equal to, okay, in triangle we will mention, and first we will write down the angles what we know. So in triangle AEC, AE is equal to AC. So I name this triangle, I name this angle as 1, I name this angle as 2, right? So for AE it is angle 1 and for AC it is angle 2. Reason? Sides opposite to, angles opposite to equal sides are equal. Angles opposite to equal sides are equal. With respect to that, this is equal. Keep this as it is. Now, let us move to the next one. What else we know here? Now we have to see. Now, apart from this, what else they have given? BD by CD is equal to AB upon AC. Let us take that. Given, or we know that BD upon CD is equal to AB upon AC. Given. But what is AC equal to? AC is equal to AE. Substitute here. BD upon CD is equal to AB upon AE. Reason? AE is equal to AC. Read from this again. BD upon CD. BD upon CD is equal to AB upon AE. Right? That means what does this tell? It is something this triangle, children, here. I'll just draw this triangle C here. So according to them, this point is A, this point is D, this is B, this is C, and this is E. AC is not joined. Assume that. According to this, BD by CD is equal, it's proportional to AB upon AE. This is converse of PPT. If the sides are proportional, then the lines are parallel according to them. By converse of BPT, AD parallel to EC. Okay? Proved? We have proved that it is parallel. Now since they are parallel, this angle is equal to corresponding angles are equal, or I can say even alternate part of angles are also equal. Now since it is there, now can I tell this angle is also equal to this angle is also 2, 1, 2 is over, I will take this as 3. I will do it here, children. Therefore, angle 3 is equal to angle 2. Corresponding angles. Okay, then Z formation. Angle 4 is equal to angle 1. I am not talking about whole angle, only part angle which I got here. Alternate angles. Right? But angle 1 is equal to angle 2 by construction. This implies angle 3 is equal to angle 4. Axiom 1. Angle 3 equal to angle 4 means BAC. This implies AD is the bisector of angle BAC. Hence proved. Right? Use angle 1 and 2. It will be easy for you. When you go on reading angles, it will be a big confusion for you. So it's better we go on numbering the angles and do it. A similar sum what we had done in the last session, the first one. We had taken that parallel and now they have given few things and we have to prove that it is the bisector. Last one, that is 10th one, and that is the last question of today's session and last question of this chapter also. We will be completing triangles chapter. Let's finish that quickly. Nazima is flying a fish in a stream. Now the main is she is not flying a fish actually according to what they have told. So she is fishing actually. Nazima is fly fishing in a stream. A tip of her fishing rod is 1.8 meter above the surface. So they have already given you the part of the figure. Let us just analyze that and let us first draw. So if she is sitting here, the fishing rod, the tip of the fishing rod is, if this is the ground, 1.8 meter above the ground, above the surface of the water, and the fly at the end of the string rests on 3.6 meter away and 2.4 from the point directly under the tip of the rod. Assuming that her string from the tip of her rod to the fly is taut. Taut is something but straight. There is no bend or something in that. How much string does she have out? If she pulls the string at the rate of 5 centimeters, she has to pull it as soon as it catches the fish, right? So if she pulls the string at the rate of 5 centimeters per second, what will be the horizontal distance of the fly from her after 12 seconds? Quite a complicated question to analyze first. Here what they have given is this distance is given. So if you assume that now she is sitting somewhere here and this tip of the rod is 1.8 meter above the water surface, right? And the next what they have given is from where she is sitting, from this point. She is sitting somewhere here, not this point. This point here is distance, when you see it is 2.4 meter. Now we have to calculate how much is the string above the water. This part, this fly of the fish what she has left here, how much is this? First we have to find that. That is the total length. Next, what we have to assume that is, if she pulls it at the rate of, they have given here is at the rate of 5 centimeter per second, that we have to calculate. Let us go accordingly step by step. Let us first write down 10th one. Let the tip of her fishing rod BA. All these things have to be mentioned. So its distance from the surface of water B AB, no, from the surface of the water B AC, this, I'm sorry, 1.8 meter. Okay, let C be the point 2.4 meter away from B. Therefore, length of the string that is length of the string that is out is AB that we have to find out. First of all, let us understand this in very simple manner. The question is still there. It is not over if you find AB. Let us find that in triangle ABC, angle C is equal to 90 degree. So AB square is equal to AC square plus BC square. Pythagoras theorem. AC is 1.8 whole square plus 2.4 whole square. So 1.8 is 3.24 plus 2.4 is 5.76. 9.00. AB square is equal to 3 meter. Okay, part of the question is over. Next, what did she do? If she will pull the string at the rate of if she pulls the string at the rate of 5 centimeter per second, let us find out that. Not assuming, she is actually pulling it. So if she pulled the string at the rate of 5 centimeter per second, then the length of string pulled in 12 seconds is 5 centimeter into 12 seconds, that is equal to length of a string we are finding 60 centimeter. The whole question is in terms of meter. So 1 meter is equal to 100 centimeter. So this is 0.6 meter. So 0.6 meter. Now that is what, if you assume here is, if she is pulling the string, that means, okay, let us take this point as D now. So what this hole is how much now? So this hole is 3 meter. Okay. Now she is pulling the string is 0.6 meter. This is 0.6. So you understood now, if she is pulling the string at the rate we calculated, we got this. So hole is 3 centimeter. 3 minus 0.6, what we have to find? At that time we will get the length of AD. Okay. Let's do that. Remaining length of the string I'll write in bracket here figure. So remaining length of the string is AD is equal to AB minus BD. That is equal to 3 minus 0.6. What you write is 2.4 meter. So this is 2.4 meter here. Shall I draw it very clearly, children? A bit this side. Even you all can make a note very easily. So this is 1.8 meter. After calculation, this is 3 meter. This was C and this was B. So if I consider this point here D, this is 0.6 and this is 2.4. Very clear? Last part what we have to find now is remaining length of the string. That is what. Now this part we have found out. Last, see what they have asked here. What will be the horizontal distance of the flight from her after 12 seconds? This distance, the horizontal distance after 12 seconds. First find this. After finding this, see for what distance she is sitting. What is the total distance from that string? So in triangle A, C, B, triangle ACD. Again, when we consider this part of triangle, this only is 90 degree. This triangle we are considering. Forget about the whole part what we have done. Angle C is equal to 90 degree. So it is AD square is equal to CD square plus AC square. So with that respective Pythagoras theorem. So AD square is 2.4 whole square. CD square we have to find out plus 1.8 whole square. So 24 square is 5.76 minus 18 square is 3.24 is equal to CD square. CD square is equal to, you get 2.52. So CD is equal to, actually you have to find the square root of 252. Now the square root of 252 is not a perfect square. How to find square root? Remember division method. 1 ones are 1. Yes. I will give the answer approximately here, but you do the division method and find the square root. So you will get approximately about 1.59 meter. This is not the end. The sum still continues. So last part. What we have to write here is, now if you see the initial part what they have given here is, now this 1.2 meter is nowhere mentioned in the question. If you see in the figure, that is this distance. Exactly, if you see here total, this distance what it was there, 1.2 meter. That is nowhere mentioned, but it is given in the figure. Read. If she pulls the string at the rate of 5 cm per second, what will be the horizontal distance of the flight from her after 12 seconds? So the horizontal distance from her after 12 seconds is, you have to add this measurement and this measurement. Total measurement what you have to measure and then write. Final answer you can just write here is the horizontal distance. I'll write here. The horizontal distance of the flight from her after 12 seconds is 1.59 plus it is 1.2. So 1.59 plus 1.2 is how much? 1.59 and 1.2. So you will get 2.79. This is the final answer. 2.79 is the horizontal distance of the flight question, but practice it. If you practice such several different types of sums, you will have an idea how to give an approach to such sums. With this we complete the chapter triangles, all the exercises, the theorems as well as the optional exercise. Thank you.